me at all, but Ken Davidian.
Thank you, everybody. I'll give you the 30 seconds. Bachelor's in Aero Engineering from the Ohio State University. Master's in Mechanical from Case Western Reserve. Got that while I was working at NASA Glenn. Started in 1983. Stayed there till 2001. Jumped out. Worked for Paragon, that lives just down the road a little bit. Worked for them as a consultant in Berlin, Germany for about a year. That tanked. Went to X-Prize. Worked there for about a year. That tanked. Went back to Paragon. And then my wife got a job back at NASA headquarters. So we actually moved to Washington, D.C. about 5 years ago. I started off as a contractor at NASA headquarters, working on Centennial Challenges, became a civil servant, became the manager for Centennial Challenges. About a year ago, left NASA and went to the Federal Aviation Administration because I wanted to see a different government agency. I'd worked for NASA for about 19 and a half years. And so I wanted to see a different federal agency. I wanted to see the regulatory side of things. I'm very, very interested in commercial space. And so the FAA, Office of Commercial Space Transportation, is the place to be. At NASA, by the last year or so that I was there, I was basically a cheerleader for commercial space. And George Neal, the head of AST, Office of Commercial Space Transportation, said, Ken, I want you to do the same thing for FAA. And that's why I'm called the Encourage, Facilitate, and Promote Program Lead. Basically, I'm a cheerleader. And so we got about an hour to talk, and so that's way too long to talk, for you to expect anybody to listen. So I'm going to talk for about 20 minutes. First part of the talk is going to be about what is AST, what does the Office of Commercial Space Transportation do? And then we'll take questions, whatnot, we'll take a breath. And then I'm going to talk about what we're doing in something I'm calling, you've heard of participatory exploration. NASA's been trying to figure out what's, participatory exploration, how to engage the millennials and stuff. So I thought, wow, this would be fun to have a participatory regulation. And so I'll tell you about things we're doing, basically research that's related to regulation. So to the regulatory environment. So we'll talk about that in a little bit, and that's where students can absolutely get involved. So first of all, that's what we're going to do. First of all, this is where I work. It's at 800 Independence Avenue in Washington, D.C. Actually, this is Maryland Avenue. This is the back of the building. If I were going to put this picture here, this is the picture I would have put up. This is the front of the building. A couple years ago, SpaceX had a model of their Falcon 1, and they brought it to Washington, D.C., and they parked it out front, so that was very cool. So, and this is our building. That's the front of our building. It's a non-district. It's called the FOBA, the Federal Office Building A. It's kind of, and then the FAA got clever, and there's two buildings side by side. One's called Orville, and one's called Wilbur. So we're in Orville. So anyways, our office, the Office of Commercial Space Transportation, was created in 1984 with the purpose, basically, of regulating the commercial space transportation industry. But there's a couple facets here I want to emphasize. Number one, only to the extent necessary. We need to regulate judiciously to make sure we don't stifle the industry. We want it to grow. Even in 1984, when the regulation was written, when the authority was written, the expendable launch vehicle, the big launch vehicles like the Atlases and the Deltas, they were just starting. The commercial sector was kind of brand new in the minds of people. And so even then, Congress said we need to regulate judiciously. And the second part of this that we want to highlight is why we're doing it. And that's basically, we always say public safety. Well, that's part of it. It's to ensure compliance with international obligations in the U.S., to protect public health and safety, to protect property and national security and foreign policy industry of the U.S. So basically, I have another chart I didn't put here, but it's like a triangle. There's three sides of the triangle that you need to balance the interests. One is public interest, one is government interest, and one is the business interest, the industry's interest. So you need to balance that, and it's a very hard balancing act to do. So the other part of our raison d'etre, but the other part of our mission is to encourage, facilitate, and promote, and that's what I talked about a little bit earlier. And we are the only part of the FAA that has that in its mission statement. The aviation side of FAA used to encourage, facilitate, and promote, but about, I don't even know how many years ago, the JetBlue accident in Florida, after that accident happened, the industry actually came to the government and said, take that encourage, facilitate, promote mission goal out of the FAA's charter, and they did. Right now, we're the only part of the FAA that has this element within its charter, and that's basically my part of the job. So, what do we regulate, and how do we do it? What instruments do we use? Well, first we use licenses. Licenses, there are many different kinds. For expendable launch vehicle operations, we use launch licenses. For reusable launch vehicle operations, we use mission licenses, because for an expendable vehicle, it goes up and it's gone. You throw it away. So you only need a launch license for that one time. But for a reusable vehicle, it's going to launch many, many times. So you have mission licenses. So that's something that's relatively new for us. And then also for site operations, so spaceports where there will be launches and maybe even re-entries, we regulate those as well. We provide licenses for that. So what I should note here is you see the word operations here everywhere. We don't license vehicles, we don't license people, we license operations. We want to make sure that the operations are safe. So licenses are the first things we do. We have experimental permits as well, and those are something that's relatively new. In the Commercial Space Launch Amendments Act of 2004, which is an amendment to our Authorization Act, that said that keep doing all the great things you're doing, but now you can also provide something called experimental permits, which allows companies to do sort of R&D flight testing without having to go through the piles of paperwork required to get a license. So it's sort of like a light version of a license. It's a little bit easier to get, maybe even a lot easier to get. It takes less time to get, and it allows these operators to do a lot of experimental testing. One of the limitations, though, of working with a permit is that you can't do any types of operations for hire. You can't make any money doing this. So for example, if Armadillo wanted to work under an experimental permit to fly its quad vehicle up and down, do some vertical flight tests, and they wanted to stick a camera on there and charge people $1 a fee to watch be on the flight, go up and down, you can't do it because it's under an experimental permit. If they want to charge for services associated with the operations of that vehicle, they have to go for a license. And then finally, we have a thing called safety approvals. This is something, it's sort of like a seal of approval that the Office of Commercial Space Transportation can provide to systems that go into a vehicle. Systems associated with safety, systems associated with the human spaceflight participants, for example, the suit. It could be a component, a subcomponent. You can bring your widget to us and say, I want this to be evaluated by the FAA, Office of Commercial Space Transportation, and I want to get a safety approval for it. And we could go through a process to evaluate it, make sure that it's good and it won't blow up or whatever, and then you'll get a stamp of approval. And then the theory is that the companies could take this widget and then go to a vehicle operator and say, hey, listen, this has already got a seal of approval. Buy it from me so you don't have to deal with the FAA on this guy. And so we do offer safety approvals. To date, we have issued none, but we plan to issue some. We have some are in work, but we're working on it. And what we're doing, a lot of this stuff is groundbreaking for the government. The government hasn't licensed reusable launch vehicles all that long. And so a lot of this stuff, we're doing it on a trial and error kind of process. And then finally, we do not license certain things. And those are launches by and for the government, DOD, NASA. And then also we don't license the operations on federal ranges. We might work with the federal ranges to make sure that the operations that are required at those ranges are in compliance with what our regs say, but we don't regulate those ranges. So, just for some eye candy, here are certain types of things that we regulate: expendable launch vehicles, air launch vehicles, the launch and reentry sites, human spaceflight operations, launch and reentry of vehicles, and then also even sea launches. Now, I guess I really didn't mention much about human spaceflight, but in the Commercial Space Launch Amendments Act of 2004, our ability to regulate human spaceflight participants was added to our authority. So, that's that. I don't know if you can see this, and hopefully the folks on Ustream can see it, but it's going to be really hard. This is a map of the United States, and it shows the different spaceports and launch sites around the United States. Now, the ones in red are federal launch sites, and the ones in blue are spaceports that we've licensed. So to date we've licensed 7, and I don't know if all 7 are here. 1, 2, there's Kodiak, there's California, there's Mojave, there's Spaceport America, there's Oklahoma, there's Mid-Atlantic, and down here, Spaceport Florida has been licensed as well. So this is out of date. So we've got 7 that we've licensed so far. And so they're around there. They're around the United States, all over the place. There are a bunch of others that are being considered in states such as Wisconsin, for example. And here are the different types of launch sites, whether they're coastal, or whether they're out in the ocean, whether they're horizontal takeoff and landing only, or whether they're vertical takeoff. So it's all different types of launch sites that we regulate. Now, there's always questions of who needs a license And who needs to go through this process? Well, if you're a US company, you need to do it whether you're launching inside or outside the United States, period. If you're a foreign company, if you're launching inside the US, you need to work with the FAA. And chances are you need to work with your own country's regulatory authority as well. Now, granted, there are not that many regulatory authorities for commercial spaceflight in other countries yet, but that will be coming soon, I'm sure. And then also, all the launch and re-entry sites, of course, need licenses. So, and I've listed over here the people that need experimental permits, and these are reusable suborbital rockets, basically are the only folks right now that may obtain this type of permit for R&D and gathering data that can be used to get a license, and also for some crew training. So, there was a ruling by the General Counsel in FAA about a year ago that said, you know, we've been watching Armadillo hang underneath this crane and then take off and hover for a while, do these tethered tests. And we think that's a launch. So even though we haven't required you to get a license or a permit up till now we require it. That's a launch and that requires a license. And so that was a ruling that came out that kind of freaked everybody out, and everybody was hitting the roof. Because now all of a sudden, teams that were doing all their testing, kind of impromptu kind of testing, they couldn't do it anymore. They needed to go through the whole regulatory process before they could even fly on a tether. About 2 weeks later, and everybody's hair was on fire and everybody was mad and stuff. And then about 2 weeks later, we came out with a ruling. We knew this was happening, but you can't say anything when you're inside the government. We came out with a ruling that basically said, there's this thing called the amateur rocketry rule that originally said you could fly without a permit, without regulation, if your vehicle has less than 200,000 pound-seconds of total impulse, if it has a total burn time of 15 seconds or less, and if it has a ballistic coefficient of less than 12 psi. I think those are the right units. So a lot of the vehicles could not fly under amateur rules because they exceeded the 15-second burn time limit. About 2 weeks after we came out with this experimental, or this ruling about launches being, or tethered flights being launches, we came out with another ruling saying we're going to remove the 15-second burn limit on the amateur rocketry rules. So now, even the Lunar Lander Challenge flights, all but the most extreme flights, could be done under the amateur rules. Staying under this 200,000 pound-second limit for total impulse was the trick, and they could do that. They could fly the Lunar Lander Challenge without exceeding this limit, therefore they could fly under amateur rocketry rules, therefore they didn't need a license or a permit. All they had to do, sort of double-edged sword, they didn't have to deal with us anymore, and we knew who they were, they knew us, we had a good working relationship. They had to go deal with air traffic control, another part of the FAA, which is kind of the big beast in the room. FAA, just as a point of reference, has 44,000 employees, and 33,000 of those employees are air traffic controllers. So the Air Traffic Control Organization is the FAA, basically. You know, you've heard of if it's good for GM, it's good for America. Well, if it's good for air traffic, it's good for FAA. And air traffic had never seen Armadillo. Air traffic had never, it's like, it doesn't fly, it's not a plane. It's like, holy cow, what is this thing? So it was sort of a double-edged sword, the fact that they didn't need to get a license or permit. They understood, we understood how to work with them, and they understood how to work with us. When they had to go through air traffic, it was a little bit of a different animal. It caused some problems. A bunch of other people started waking up to what's going on, which is a good thing ultimately, but there was sort of a little bit of future shock going on within the FAA. But ultimately they got the problems worked out, and as you know, the Lunar Lander Challenge flights took place. Let me talk for a couple seconds about commercial human spaceflight. These are the regs that came out in 2004, or at least the direction came out in 2004. The regs were finally passed in 2006, and this is it. And the regs are actually not that scary to read. They're kind of fun to read if you need help going to sleep, basically. But there are a lot of them. This is where you find them. They're actually very interesting. They're in plain language. You can absolutely understand them. They're not written by a team of lawyers cloistered up in an ivory tower. Basically, it says that Congress finds that the regulatory standards governing human spaceflight must evolve as the industry matures. So we're not going to try to stifle the industry. We want to make sure that risks that are known are avoided, and people are aware of them, but we want to make sure that the industry has a chance to grow up. Now, there's certain Congress people that seem to think that this is the worst possible idea in the world, that you're asking for an accident, that somebody's going to get killed, and it's called a tombstone mentality. And it's it's true, we're being allowed to take risk. We're asking our Congress to let industry take risk. And to their credit, they have allowed that to happen. So we'll see what happens over time. The government is not obliged to put too much regulation on commercial human spaceflight, at least until 2012. When this was passed in 2016, we thought for sure people would be flying by 2012. You know, it would be an everyday occurrence. You know, so hopefully, if plans stick according to schedule, there will be commercial human spaceflight by 2012 with Virgin Galactic going into service next year. But it's not going to be to the level that we expected. So we're trying to get that limit extended beyond 2012. But for now, this is where we're at. So we are able to regulate commercial human spaceflight. People that fly on these vehicles are not called passengers because that implies some level of guarantee of, or low risk, guarantee of safe passage. They're called spaceflight participants. They have to be made aware of the known risks. They have to be made aware of all of the risks that have taken place in all human spaceflight in all time, all over the world. So, but it's not impossible to meet the requirements that Congress has imposed. So that's what we're doing. That is the end of the regulatory part of the talk. I'm going to do what it says. Are there any questions? Yes, sir.
Can you double that total ISP for us?
Can we double the total? The question is, can we, instead of 200,000 pound second total ISP limit, can make it to 400,000? I don't know. I don't think so. I don't think you want to. I think the ability to fly a Lunar Lander Challenge profile without having to go through a regulatory process or permitting or licensing process is pretty darn reasonable. I mean, to be able to put Quad or Scorpio or whatever in the air for 3 minutes and to fly, basically what would get you from the surface of the moon into lower lunar orbit, that's pretty reasonable to do that with a minimum amount of regulation.
Sure, but they had to put like expensive composite tanks on it and reduce the weight, and they wasted like 3 weeks.
Oh my God, 3 weeks.
I know.
Okay, next.
Sure.
So where does the definition between commercial and like research come in?
The question is, what's the difference between
Commercial space flight.
What's the difference between commercial and research? Research flights versus commercial flight. I guess if you don't hold me on this, I'm going to pull something out of my back pocket. But I suppose if you're charging, if it's a revenue generating flight, or if there's a service being provided in exchange for, money, or even for services, some sort of barter, then that would be considered a commercial activity. I suppose somebody could Google right now, get on the regs, and find out what the definition of commercial is specifically. Yes, sir.
You said a spaceflight participant is not the same as a passenger?
That's correct.
So what do you have to do to be considered a spaceflight participant?
Well, no. If you go up in one of the vehicles in the next 5 years that are available, let's say in Virgin Galactic, you'll be considered a spaceflight participant under the current regulatory regime. I don't know if there's any formal definition of passenger saying a passenger is somebody that flies on a certified vehicle, but these vehicles are not certified as safe by the U.S. government. We don't talk about certification in our office. We're not intending to certify vehicles. And so that expected level of safety and safe carriage is not part of the product being sold. Europe, on the other hand, France specifically has passed a regulatory regime that does require certification of vehicles. Yes, there was a question.
I was wondering, you mentioned part of the FAA's mission on this is to encourage the development of the industry in these sort of space flights. Like, what are you doing along the lines of encouraging that? Just trying to keep the regulations from becoming too excessive? Is that how you fulfill it?
The question is, one of the 2 missions is to encourage, facilitate, and promote a safe and successful commercial space transportation industry. What is the FAA doing to encourage, facilitate, and promote? And this is walking right into a spiel that I am going to talk about a little bit in part 2, but we're doing a number of things to encourage, facilitate, and promote. Number 1, we're working with other government agencies, as well as other branches of the government, to make sure that the regulatory hurdle over which companies need to jump to become successful is as low as it possibly can be. The Office of Commercial Space Transportation was originally set up in 1984 as an independent agency in the Department of Transportation, independent of the FAA, to be a one-stop shop for a commercial space entity to enter into the government and to get all the permits it needs from all the state, FCC, NOAA, there's a lot of different departments you have to talk to get certain permits. And now our office was created to be the one point that the commercial entity has to enter in and deal with. So that's one way of lowering the burden. So dealing with other government agencies for you. Number two, we do it by generating reports, information, doing analysis on the industry, making that available to the industry so that the industry can have a very clear perspective of what has happened, what is going to happen to help make their decisions. And so we do a lot of information analysis and dissemination. And part of that is coming out and doing talks like this, getting the word out of what's going on. So that's part of our encourage, facilitate, promote. The third thing we do is we conduct, let me think, hold on a second, because actually research and the things I'm going to talk about next come in that information and reporting kind of mission element. The third thing we do, I'll tell you out in a minute. There was a question over here. Yes, Jonathan. I'll get it.
On the last slide, it said avoidable risks as the industry matures.
Right.
That kind of language makes me ask, avoidable by whom and avoidable at what price point, and is that a moving target? Is that what the second phrase means? That's a moving target as the public comes to expect greater safety?
Well, no, you're absolutely right. And I think you came in a little late. I was talking about the triangle of the balance of government interest, public interest, and business interest. And the FAA has got to regulate judiciously, and it's going to be impossible to necessarily find the perfect balance all the time. But that's the goal. In an ideal world, regulations would only be written to mitigate potential negative social impacts of an industry on society, and those regulations would be agreed to by the industry, and because they can do the analysis and cost trade-offs and brought to the government for adoption. What happens in reality is that the government kind of gets offered the task of writing the regs, they do it, but then they open it up for public comment, so that allows the industry to get their act together, do the analysis, provide comment. So I think what they're doing is trying to balance. It is a moving target. There is cost taken into account. It is something that judiciously has to be pursued at all times. And I'm still thinking what that third element is. This is my job, I should know. Okay. Yes?
When someone does need a license for a mission or such, how time-consuming is that, and what irritations?
How much time is required for a license and or a permit is the question. For a license, it's 180 days after our office deems that the application that we've received is sufficiently complete. So that's a soft term there. But once there's enough there to start working on, and it's an iterative process, it always turns out to be very iterative. Once there's enough to start working on, then the clock starts ticking, and you have 180 calendar days. Now, for a permit, it's not 180 days, it's 120 days. But the same starting bell when the application is sufficiently complete. Okay. Any other questions? Boy, I feel stupid. It's information and discussion. It's external relations. I got to think of that third one. I'm just brain farting. Okay. We'll keep moving on. So the question is, okay, what are we doing now to encourage other people to help us with determining which way the regs should go? Participatory regulation is this idea. And basically what I'm going to be focusing on is that one element I can remember, which is information and research, information and discussion. How can we generate better analyses of the industry that will help us better regulate the industry? And so we have three different tools that we're kind of working on, three different activities that are going on right now. The first one is something I'm calling ad hoc research, memorandums of agreements that we're starting to sign with different individuals and academic partners or schools, basically. This is basically an agreement between AST and, let's say, What's a Man to You, to say, we're going to sit down with a student who has an interest in doing research in a topic that would be of interest to the Office of Commercial Space Transportation, but also of interest to the student. We're going to figure out what that topic should be. And then we're going to say, listen, we will be on the phone with you once a week, we'll send emails, we'll give you guidance in this research. Student, you do the research. Now, there's no money exchanging hands here, and I'm trying to be upfront about that. No money goes anywhere. And AST will provide time and guidance, and then AST will actually come out to your school and give presentations, work with you a little bit, do presentations for a seminar, like a graduate seminar, talk to your bosses, make them feel good, go back home. And then the student will go and do this like research. And when we're talking research here, we're talking like a white paper, what in government or what in the industry you call a white paper. It's not a master's thesis, it's not a PhD thesis, it's a thought piece. It could be 3, 4, 5, 6 pages, just some research, documented research. Just put some coherent thoughts on paper that address the issue and provide a perspective that, you know, is worthy of time. And then you'll be invited to come and to speak at our conference. We have a conference every year in February. Our next one's coming up in February, 10th and 11th. And what will happen is then we'll provide a stage, a podium, for the students to stand up and present their research to the level of completion, you know, at that time. It doesn't have to be completed by February, but you do the work, you get up and make a presentation, so it's good practice being in front of a real audience, kind of thing, live studio audience, and then you get to talk. The real benefit is you're there at the conference with a bunch of sometimes pretty important people, and you can talk about your research with these people. You can get some feedback. You basically can get a lot of input. You go back to your school, you finish up the paper, you turn it in, Bob's your envelope. You could even publish it at, you know, present it at another conference if you want. So this is one of the ways we're doing it. And in fact, we've got one of these signed. One of these is on the verge of being signed with our good friends here at the University of Arizona. Jonathan Card is our guinea pig in this school. And so we're doing things in a bunch of different areas. Like I said, no money exchanges hands here because once money gets brought into the picture, it gets really complicated with the government. I like to think that one of my jobs is to shelter the commercial world from the bureaucracy of the government world. But the truth is, I don't really enjoy the bureaucracy that much myself, and so anything I can do to minimize it, I sort of try to do that. And so doing things at no cost is one of the ways I try to minimize the pain on myself. So a second way that we're going to be doing research associated with commercial space that will help us write regulations better is something called the Centers of Excellence. Now the FAA in their authorization way back when, and I don't even know when, because now we're talking not Office of Commercial Space Transportation, but the big FAA, the FAA has something called Centers of Excellence, where basically a bunch of schools get together, they form a team, they become a center of excellence through a competition process for a given technical research area, and then they do research. And this research is funded, and it's an organization that's set up over a long period of time. Now, here, you can see I framed this memo here that's signed by Randy Babbitt, who's the current administrator of the FAA. It was signed on the 18th of August, saying, yeah, I think the Commercial Space Transportation Center of Excellence is a good idea. I think the Office of Commercial Space Transportation should run it. We're going to run it for a long period of time, 10 years, and it's going to be funded at a level within the FAA of $1 million per year. So now this is a big deal for FAA because the FAA right now, or our office, it's a big deal for our office because right now AST spends on the order of $150,000 a year on internal research. So now we're going to bump it up at least to $1 million. And oh, by the way, we're going to be doing this as grants to these universities on this COE team. And they are required by law to match every dollar they get from the FAA with $1 from industry. So now we're talking about $2 million worth of research that'll be done on an annual basis for 10 years in the area of commercial space. And it's obviously for the benefit of both government and industry. So it's kind of nice. We're in the process right now of writing the solicitation. There will be a public meeting for the solicitation in February, and the final awards are currently scheduled to be given by the end of the summer of this coming calendar year. So, I've been thinking of this Center of Excellence as a university, and as you know, a university is made up of a bunch of colleges. There's the College of Business, there's the College of Engineering, right? And there's the College of Behavioral Sciences, whatever. And so I came up with 4 basically thematic areas or colleges. One is space traffic management and operations. So this deals with all these sort of departments or schools within that college. And basically this is the system of space traffic management. How does commercial space launch and reentry operations interact with regular aviation space air traffic control. There's a whole lot of interactions and complexities going on there, and that's an area really worth investigating. Also, how do the operations at a given spaceport work? How can you make them better? What's the type of infrastructure that's needed at certain spaceports? So those are all areas that are within the Space Traffic Management College. Over here, we've got the Vehicle Systems, Launch Vehicle Systems College. Now we're looking at the launch vehicle itself, all the technologies that go into it, all the software that goes into it, the testing of that vehicle, and the operations of that vehicle. So there's a whole area of research just focused on the vehicle, and this gets into a little bit more of your standard engineering here, so looking at materials and propulsion and avionics and all that kind of stuff. The third area is this human spaceflight area, where we start looking at a lot of the biological systems, physiological effects, human factors. And by the way, I should mention that in each of these three schools, safety is impregnated, through and through. I don't have a school of safety here, but a lot of the departments underneath these colleges, or some of the schools underneath these individual departments, will be flight test safety or ground operations safety. So safety is our number one concern, and it's basically embedded throughout those three universities or colleges. Finally, we have this fourth one down here that I'm going to focus on a little bit more because, I don't know, maybe it's because I'm getting old and stuff, but I think this is the really interesting part of the puzzle right now. Now I realize that, okay, let me ask, how many people in this auditorium right now are not engineers or scientists? 1, 2. Okay, so I'm talking, let's say 2%, 5%. Let's say there's 30 people here, so 1/15, 6%. So that's a low fraction. Now, I know that the speaker before me talked about how on Wikipedia the millennial generation has been characterized as being super smart and sophisticated and stuff. So I'm sure that you're nothing like we were 30 years ago when I was in college, where all we did was make fun of business majors, as an engineering student. I'm sure that's not the case. So it's taken me 30 years to get to the point where you're at today, undoubtedly, that this is the important part of the equation right now. The people that are in that school, they're smart in different ways. Maybe they didn't get the physics, maybe they didn't get the complex algebra and stuff, but they're dealing with a system that's very, very complex. And in fact, it's definitely worthy of our study, and I think my next slide is, I'm going to say more. So let me stop here and just say, space commerce is involved not just with business, which includes economics and finance and insurance and all these other things, but there's also law, policy and law and regulation are also parts of this college. So again, these are the non-technical areas of the commercial space business. But in my mind, this is going to be one of the most important areas in the development of commercial space. Yes, Brett?
Just to clarify, is that 4 different centers of excellence, or are those all under the one?
No, this would all be considered one center of excellence. One center of excellence is going to be comprised of a lead university with a bunch of member universities as well.
Okay.
So we're going to have this public meeting, and the way I've been told it's going to work is we make a bunch of presentations like this, and then at lunchtime everybody sits around the cafeteria eyeing each other, going, oh, there's MIT over there, and there's Georgia Tech over there, and there's UCLA over there. What can they do? What can I do? And they're going to try to create this, baseball team kind of thing that can at least address many of these departments. So basically what's going to happen is there's going to be individual research going on. Let's say, like I said, in business, the College of Business, you're going to have the School of, economics. You're going to have a School of Finance, blah, 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 all these different subdivisions. So John Card might say, I'm interested in acquisition strategies, so I want to propose research in, the effective acquisition on the outcome of blah, blah, blah. And so he would then fit in there. He would get pigeonholed into this college or this school, department of this school, and we're going to say, well, let's make sure that whatever team you put together, you have at least 2 PIs, principal investigators, in each of these 4 schools. So we'll see how that comes out. I'm still writing the solicitation right now. I'm expecting the draft solicitation out sometime before Christmas. I used to say December 1st, but that's when I get back to the office. So. Okay, so anyways, as I was saying, the business problems are the biggest hurdles right now in commercial space. Yes, technology is fun, and yes, a lot of the entrepreneurs right now are approaching the problem in a technological way. You've heard the saying that when the only tool you have in your toolbox is a hammer, every problem looks like a nail. Well, when you've been studying math and physics, for the last 8 years, or doing that as a job for the last 20 years of your life, and now you're going after a new problem, and ooh, I can make this rocket go higher or faster, and you're going to attack it from a technological point of view. But guess what? NASA did this technology 40 years ago. It's not a problem. They took it to what's called a technology readiness level of 9. That means they integrated it with a bunch of other technologies, and they flew it, and it worked. The guys that are the entrepreneurs in the emerging industry today, they're taking those technologies and taking them off the integrated systems. They might tweak them a little bit, but just by merit of taking them off the system, they bring it back down to a TRL level of 6. Now they're starting to integrate them in a different way. They're starting to put them together, and that's hard. Integration is hard. That's the hardest part of the puzzle. But basically they're taking TRL 9 technologies, putting them together back at 6, and they've got to get them back up to 9 by flight testing them ultimately. It's very difficult, and it's taken the Lunar Lander Challenge teams 3 years to get to the point where they could actually do that task. So technology is a big problem, but finding new customers for products that don't exist today, for capabilities that existing customers don't think they need, that's a marketing issue. That's a people issue. And we went into engineering for a reason, right? Supposedly we're a bunch of nerds. And these issues, these business issues, are what we really need to solve, because the business is out there. Okay, let me do a stupid poll. How many people here want to go to space? The market's there. I'm sorry. Do you care if it's 60 kilometers or 100 kilometers? If it was $20,000, you can get to, it's the price of a car. Once you're out working and making some real money and stuff, just say, I'll keep my beater for another 5 years. Not a problem. I'm going to go. And so that's where I think the problem is right now. It's business. The technology is important. We need to work on it and stuff. But nobody's out there using unobtainium and flying space elevators, laser powered, even though they did recently. But anyways, this is the real issue. That's why I'm focusing on the business section. And again, we would never make fun of our colleagues there, but we need to start embracing them and bringing them in and getting them excited about it. So what I've been doing, and I was just talking with John this earlier, I got one of these as a Kindle, and I've been reading. And what I've been reading is business textbooks. And like any good engineer, you've heard of Bernoulli's principle or Newton's theorems and all that sort of stuff. There are theorems out there about business, about how business works. And some of them are pseudoscience. Some of them are based on statistical history, historical events of businesses. Like any theory, they've got limitations. But like any theory, they've got predictive capabilities. And as you know, if you could predict if you could tell what's going to go on tomorrow, you could be rich, right? If you could make any type of prediction, you could make a mint. Well, these theories give you some capability of predictive powers. Now, would I bet my life on these theories? Probably not. But what's nice about them is they provide a formal structure of somebody who's really smart, sat down and looked at the entire landscape. It's not just me sitting here, It's not just me sitting on a panel saying, I think this and I think that, pulling stuff out of my back pocket. It's an academic who has looked at every possible angle of the problem. And they've formalized the structure, and they've also formalized the vocabulary. But if you go talk to somebody and say, hey, what do you know about innovative or disruptive technologies? They're going to know exactly what you're talking about, and they're going to tell you. But guess what? They're wrong. What you're thinking about is different than what they're talking about. You're using the same words with similar concepts, but it's just different. So what happens is, by using a theory as a fundamental basis, you've got commonality of vocabulary. You've got predictive capabilities. However, we need to defend the theories and their application, because, in fact, some of the most vocal critics of these theories are business people themselves. A lot of business folks don't use these theories in their application, and so they'll tell you it's not worth it. It's, oh, that's theoretical. Go out and get your hands dirty in the real world, they'll tell you. And they're absolutely right. However, from the US government's perspective, if I'm going to put $500 million down on the COTS program for commercial orbital transportation services, and I can look at a theory and it says, well, if I put it at this point in the marketplace, you're going to have this outcome, but if I put it over at this point in the marketplace, you're going to have a better outcome. I want to know that before I put that $500 million of taxpayers' money on. So the government basically is what I'm saying, that the government should use it to help defend their acquisition strategies and their policy decisions. And I think as a taxpayer, that would make me feel a little bit better to know that the decisions are being made based on something other than somebody's wild guess. But it doesn't happen today. Oh, so anyways, I was going to run through real quick. one of the theories I read on a book called Innovator's Dilemma and Innovator's Solution, there's something called the disruption theory, and you've probably heard of those books. They were written in 1998. And so basically, and I'm not going to go through too much detail here, but basically see this dark black line, it says, as time goes on, some performance metric increases over time. The product gets better. Okay, and there's a bunch of other lines on here, but don't pay attention to that. But basically, product gets better over time. So, and by the way, there's 3 different ways that you can look at this graph. One is called a sustaining innovation, where you just make the existing products better and better and better. There's another one where you make the existing, or you take something like the existing product, make a poor man's version of it. It's cheaper, it doesn't perform as well. So the customers up here don't want it, they want something better. But you get some other people who are a little bit, don't have as big of pockets, and they just want to go to space to 60 kilometers instead of to 100 kilometers, but they can do it cheaper. So that's called a low-end disruption. Then you've got something where you don't even use the same performance metric. You use a totally new performance metric, and you go find a whole new market. This is hard. This stuff is hard. Talking to the customer, finding out what they want, and making a better product, of the 3 types of innovation, that's the easy one. But what's happened is you got a bunch of competitors up here. They're going to come and attack you. And 95% of the time, they're going to beat you. So that's a competitive risk is very high here. Technology risk is high. You've got to do something better than everybody else. Yeah, marketing risk is low. You know who the customers are. But it's a trade-off. So you got all these kind of trade-offs. So anyways, I looked at suborbital flights. There's about 14,000 data points here. These are suborbital flights around the world. And the fun part of this is right down here. All these red squares. You can barely see them. Red squares with black outlines. Those are the V2s. But anyways, you kind of see, so I look at this and I'm going, I kind of see a pattern. There's this increasing performance over time. I mean, I'm not seeing things. There's a cluster here about 100 kilometers. There's a cluster here up at 300 kilometers. And it kind of goes up and levels off in reality. But you kind of see those increases in time. So to a first order of magnitude, I'm saying, hey, disruption theory might apply here. It might really apply. So anyways, I've taken that paper and I've written about it. I've talked, and I didn't want to go into a lot of detail, but I've written a paper that says, well, the guys that are going into the commercial payload or suborbital payload market these days, Armadillo, Maston, Virgin Galactic, they can go in at different points in the marketplace. And depending where they go, they're making trade-off of those different types of risks. And I'm not telling them how to run their business, that's fine. But if the government is going to put $2.5 million of its money up to buy launches for scientific payloads, which it should know what the implications of it, saying that the launch must go to 100 kilometers. That's putting the pot of gold in a certain point that is going to drive the market there. And it's going to drive folks to a certain set of risks. But if they say it's fine to go to 60 kilometers, if they put the pot of gold at a lower point, there's going to be maybe a little bit better set of risks. That's going to increase the chances that that market will be successful. And that's ultimately what the government's trying to do. So, I was telling Brad Cheatham, that these are basically the papers I'm going to write next year. So one is this Clayton Christensen disruption theory in the emerging suborbital payload market. That's what you just saw a little bit of. Also, we're doing ad hoc research projects, the impact of government acquisition tools. That's what John Carter's doing. And then lastly, I'm doing this thing up at Ames, a conference called the Next Generation Exploration Conference, the 3rd one. And we're going to be focusing on another theory out there, Michael Porter's theory, the 5 forces theories of the market, where we're going to do one of his 3 types of analyses called an industry structural analysis. But it's going to be really, really interesting. We're going to be looking at the emerging commercial space markets of suborbital cargo, suborbital human, and orbital cargo market sectors. And you're going to be looking at what are the barriers of entry, what are the barriers of exit, what's the bargaining power of suppliers and the bargaining power of customers. It's a theory that's out there. It's a theory that has credence. It's a theory that we can really make predictions from. And so we're going to have 130 and unders at this conference working on this stuff. And you should be hearing more about this soon. We don't have tons of details out on it yet, but we've been preparing to release them. It's not until April, 5 through 8. So anyways, in summary, we talked about what AST is, and I wrote AST is commercial space transportation. And my motto is, I'm working hard to keep commercial space safe for yet another day, and I am. And we're doing participatory regulation. Couldn't be any more fun than that, right? Because people think of regulation and they think how boring, but it isn't. It could be a lot of fun. So, and we're doing it in 3 ways. 3 ways that you, and you can get involved is through ad hoc research, through the Center of Excellence or by participating in our Next Gen Exploration Conference. For more information, of course, you can send me an email, ken.davidian@faa.gov. Are there any questions? Yes, sir.
How can students volunteer and help you, Ken?
Ah, good question. I forgot to put on my slides here that I'm also the head of a group within AIAA. Who here knows what AIAA is?
A member.
The American Institute of Aeronautics and Astronautics. This is a fairly traditional group of the traditional aerospace and defense industries. However, about 2 years ago, they came to us and said, there's something going on in commercial. What's going on? And so they started a group called the Commercial Space Group. And despite my protest and the protests of everybody else, they asked me to chair it. And so, so I've been leading this group now, and Brad's on the group. And we're basically an organization trying to get the information about commercial space out to the public, to the traditional aerospace industry members, as well as to try to get information about AIAA and the traditional industry lessons learned, if you will, to the emerging commercial space sector. So, if you'd like to participate in that, please do not hesitate. I would say send me an email, but it's probably much better to send an email to brad.cheatham@gmail.com. So if you send it to me, I'll just forward it to him. And we'll get you working on stuff. We're going to have a lot of fun. We're doing a lot of fun things. We take industry visits. If you go to the Commercial Space Wiki, if you Google Commercial Space Wiki, you'll find my page. It's commercialspace.pbworks.com. We go on industry visits. We've gone to Mojave twice. We went down to the Cape once. We're going to the Cape again in January. And we host sessions, paper and panel sessions at most of the AIAA, relevant AIAA conferences, and all that sort of stuff. Any other questions? Yes, Kyle. I got 2 minutes. Any other questions? None? Yes, sir.
So I guess this is from a while back, but when you were talking about how you guys want to be the one-stop shop, or we're set up to be the one-stop shop for space stuff, is there any kind of stuff you guys do to help all those space companies, like say Armadillo, for instance, go through the other 75% of the FAA, which the flight controllers?
The question is, how do we help the applicants that come into our office go through the other steps of the other parts of the government and getting their applications through? And the answer is yes. One of the major ones is the environmental studies that have to be done for site operations, launch and reentry site operations, as well as vehicle operations. And so we do work with, we kind of play the intermediary between the applicant and the other government agencies. ITAR obviously is a big regulatory hurdle for everybody. And to be honest, since I'm on the encourage, facilitate, and promote side and not as much on the regulatory side, I can't tell you how much we fit into that plan, into that process. But we do try to make the hurdle as low as possible. And in fact, if you talk to the companies, and in fact, not even us, we didn't talk to the companies. The Tory Group, which is a think tank in Washington, D.C., they were commissioned by the Commercial Spaceflight Federation to do a study, a survey of their member companies. And one of the questions that they were surveyed on was, how's FAA Office of Commercial Space Transportation doing? Thumbs up, thumb down. And actually, we got a really good grade. I would say we got an A, even an A+. So the industry thinks we're doing well. In fact, I'll share something with you. When I get, people come and talk to you and say, oh, I've got great ideas, I want to do a study on this, that, or the other, and they always identify an issue of, we have to minimize the regulatory burden on the industry. And at this point, you can tell that individual is like kind of new to the process. Because if they talk to the folks, if you talk to the companies, talk to Armadillo, talk to Mastin, talk to X-Corp, they're happy with how we're doing. We really are trying. Can we be better? Sure. And we always try to be better. Any other questions? Kyle, we're done. Yeah. We are done. Thank you very much for your time.